Hello everyone, I trust you are all as well as can be. Welcome to Frontline Systems webinar on forecasting and machine learning in Analytic Solver, an overview of automated risk analysis of machine learning models. I am Dr. Sima Maliki and I would like to thank you for joining us in this virtual gathering. You're welcome to email your questions to consulting@solver.com. I look forward to hearing from you. Today we will focus on machine learning and predictive analytics using Analytic Solver, our all-in-one product. We will look at what you can do within and beyond Excel with an overview of recent and advanced capabilities. This is along with a brief introduction to Raison. This is another product of Frontline Systems. We explore our AI agent for modeling support. Then, starting with one of our latest enhancements, synthetic data generation, we will also assess the risk of a machine learning model before it is deployed. Then, we practice finding the best supervised machine learning algorithm. We will create a multi-step data science workflow. This is combining various machine learning techniques. And this is as easy as dragging and dropping icons for each step to train and compare multiple algorithms. After that, I show you how with only a few clicks you can deploy your machine learning workflow to the Azure cloud to run it as a cloud service using Analytic Solver plus Raison. Analytic Solver is an all-in-one solution. This means that it completely equips you to perform data visualization, forecasting, text mining, machine learning, and other predictive capabilities for large data sets. Moreover, it enables you to model and solve deterministic and stochastic optimization models, model and run Monte Carlo simulation and risk analysis, employ decision analysis with single-stage and multi-stage decision trees and decision tables with full compliance with DMN rules. Analytic Solver runs on Excel for Windows, Excel for Mac, Excel for web, and works really well with Microsoft Teams. It also allows you to go beyond Excel with point-and-click deployments of live models to Power BI, Tableau, and much more. But this is not the only product. This is just a starting point. We offer much more. This includes other platforms, including Raison Decision Services, Solver SDK, and Excel Miner SDK, which is for data mining. Raison is the cloud platform offering decision analytics for Microsoft Cloud that offers a REST API. We will get a little familiar with Raison today. I'm going to skip the details for now. Excel Miner SDK platform offers developers you can work in C++, C#, Java, Python, or R, and it offers you a powerful high-level API for predictive analytics. And then Solver SDK, powerful API for prescriptive analytics offers you. Now that you're more familiar with our overall picture of the product line, let's open Analytic Solver for a quick review of data mining ribbon. Okay, let's make sure everybody can see this. This is Analytic Solver ribbon. On the top, let's start from top left. Model tab displays or hides the task pane on the right side. Then you have Get Data. Get Data allows you to draw a random sample of data or summarize data from various sources. It could be another Excel worksheet, Power Pivot spreadsheet data model, which can be anywhere from 10 to 100 million rows of data in Excel, an external SQL database. It could be Oracle, DB2, SQL Server. It could be another data set with up to billions of rows across many hard disks in an external big data computer cluster running Apache Spark clusters. Okay, so that's the big data. So these are different ways you can get a statistically representative sample of your data. Before starting with generate data example, let's talk about AI agent. Analytic Solver offers an AI technical support agent based on the same technology as ChatGPT. It had studied thousands of pages of frontline help and user guides, everything about optimization, Monte Carlo simulation, data science, machine learning, and much more, and it's available for you to be utilized. Let's just type in like one question. How about text mining benefits? Just came back as I requested. Text mining has several benefits. It's telling you all the benefits, and if you click on learn more, it actually tells you exactly where you can find more information in the user guide, which page, and much more. Okay, let's close that and let's start with generate data. This icon, generate data. Let me give you a little background. Synthetic data generation is used when there isn't enough original data or when use of the original data, for example, is restricted by the law or regulations. Today, in a few minutes, we will explore how to use it to better train machine learning models. This tool can accurately model the behavior of nearly any combination of features with continuous values. This is a loan data set that I have here, and our ultimate goal is to create a model that's going to predict if we should grant an applicant a loan or not. Just before starting, let me show you. So let's see. So this is the loan data. This is the data source for this loan data. It's publicly available. And these are some of the features. So imagine we build this model and put it in production. And once it's being used, we find out that the income column, for example, in the original data set had only values between 50,000, 60,000. Later, the model is in production, someone comes to the bank, apply, and the applicant with an income of 12,000 applies for the loan. The model performs poorly, loan is granted, even though it is going to default because we haven't seen that case before. The traditional solution to this was to adjust the machine learning model by retraining it with new data that has like all these 12,000, 11,000 in it. However, in real life, perhaps many of bad loans are given and resulted in defaults and hence adverse financial consequences before the model is retrained. Quantification of such risk ahead of time has been missing in practice. Now, this is the good news for you. Our development team invented ways to automate the entire risk analysis process and made it as simple as checking just one box for having such capability, and it's called Simulate Response Production. It is available on the fly on all the algorithms. I'm going to practice it next. Now, as part of that, there is synthetic data generation. So synthetic data makes sure there are data points that cover all possible outcomes and avoid future poor performance. And then how does it work? Let's get started and then I can explain further. Let's click on generate data. Let's select all the variables, move them to selected variables. And okay, so it complains about the non-continuous variables. Okay, so we have to kind of skip the credit policy and purpose. They're just text features. And then click on next. So here you have the distribution fitting. And you can see, you see metalog terms and metalog selection test. Okay, you can choose that. And then there are fitting options. So how does this work? Very simplifying it, it's complicated, but I just want to say it in very simple words. It does something like this. We take the column, for example, income data. We feed a metalog distribution against the original data and optimize its parameters. We use metalog family of distributions because they're very good for fitting data. And then once we feed a psi metalog distribution, then we generate samples from it. And you can do that for multiple columns at the same time, just what we're doing right now. So we have fitting options for metalog distributions. These are controlling the automated fitting of metalog and probability distribution for each feature. And you can easily adjust, control, remove, and add upper and lower bounds. So just add an update. Then you have correlation fitting. Correlation fitting by default constructs a rank order correlation matrix that includes all of the features. If you choose copula, it activates the advanced button. Let me just quickly show you. And then you can choose the type of copula you want to use. Let's just keep the default. There are sampling options. You can generate sample. I'm just going to show you a sample of 1000. The advanced option of what sampling method, what sampling generation method you want to use. And you can get different reports. Let's get a distribution fitting report and some charts. And we can click on finish. So here are the results. Let's first go to synthetic data sample worksheet. We can see that we have frequency histogram of known cases versus simulated or synthetically generated cases. The original data appears on the top row and the simulated or synthetically generated cases appear in the bottom row. So this is for installments, for example, and this one is for synthetic data. Let's, for example, look at DTI, debt to income ratio. You can just scroll to the left, DTI, let's have on top of each other. And you can see that it's there's a difference in the simulated cases, with more frequent cases having a higher debt to income ratio. And remember that differences in this data gives rise to the uncertainty and risk in the performance of machine learning model. We want to make sure we cover all the data points, right? So this is part of risk analysis of machine learning models. So this will be automatically done while we're doing the risk analysis, okay? But I just want to show you as a separate tool. It's also available to be used to create synthetic data. And there are other outputs here. For example, the distribution fitting, all the methodological bounds are presented, and all the coefficients. Here's the goodness of fit test and much more. Okay, back to Ribbon. Next, we have the Explore tool. It allows you to visualize your data and provides you with feature selection and analyze data capability. I will show you Chart Wizard. I will show Analyze data later on if we have time. Okay, it's pretty straightforward. Let's click on Chart Wizard. Very quickly, you can, for example, choose a scatter plot matrix. And once it's ready, I'm going to remove a few. Okay, that's good. Let's add the FICO score, which is easier to follow. We have FICO score, and then we can also, on the top right, you have option to color by. For example, look at the scatter plot, color by the not fully paid. So the not fully paid, it has two outcomes, 0 and 1. It's our output variable, and 1 is when the borrower is defaulted and did not fully paid off the loan, and 0 means they did not default, okay? And then, for example, with the FICO, you can see when the FICO score is above this, the number of defaults are less on this, right? So on the right side, you have other options. You have filtering options on the right side, and you can choose which variable to include or not, and much more. Just want to quickly show you. It's very easy to work with the chart wizard. And this is like 5,000 rows of data, I think. With analyzed data under Explore, you can generate a multivariate chart for any number of continuous or categorical variable, and it can be used as a standalone application, but also it can be useful in a step in understanding your data while in the process of building your data mining model. Feature selection has been part of our analysis of data mining for a long time. This help you find out what are the features has the most predictive power. Okay, next we have Transform. This is all the tools for data handling utilities to clean your data, missing data handling, binning continuous data, transforming categorical data, and principal component analysis. We have two types of clustering. Clustering or data segmentation, we aim to group or segment a collection of objects, observations into subsets or clusters. We have hierarchical and k-mean clustering. K-mean divides the data into set number of clusters and assigns each record a cluster while minimizing distance within each cluster. And in a hierarchical, a series of partitions take place, which may run from a single cluster containing all objects to n clusters, each containing a single object. Next, you have text mining capabilities, allowing you to gain insights from your unstructured text data. Then you have time series. As time allows, I will also show you an example of time series. So we have partitioning of time series, and time series are a set of observation on a quantitative variable collected at equal time intervals usually, and they're usually equally spaced intervals. You have ARIMA methods for time series, and you also have smoothing techniques. Okay, and lag analysis is also available. You have all the way from exponential to moving average and Holt methods. Now, to data mining. So you have partitioning of data mining data sets. You can partition your data to training, validation, or test sets. Now you have also the synthetic data. So your models can be trained and evaluated. There's also partition on the fly on the ribbon under each algorithm that we can use. Now, imagine you have a data mining project. You may want to predict a fair market value of a house or how many units of your product a customer will purchase in the future, or you want to classify whether an online transaction is fraudulent or not, or insurance applicant is high, medium, or low risk, just like the data set we looked at. In all of these scenarios, the goal is to predict an outcome based on a set of features. So you can use supervised learning algorithms. Predict enables you to identify a value for a continuous outcome. Classify allows you to predict a discrete categorical outcome. You have access to 10 supervised learning techniques, including 6 classification and 4 prediction methods. And you also have the capability to build better classification prediction with ensemble methods available for both prediction, 3 different ensemble methods, and 3 for classification, bagging, boosting, and random trees. Analytic Solver also offers augmented machine learning features. You can choose to find the best model, and our software will automatically test and fit parameters for multiple types of machine learning models, classification, regression, all of those, and validates, compares them according to your chosen criteria, and delivers the model that best fits your data. And we talked about the risk analysis. And now it's a very good time. Let's actually practice risk analysis together and see how it can help us to avoid some mistakes. Let's click on classification tree. I will show you that. A cell is selected within the data. That's the best practice. Classify, classification tree. So we're going to skip credit policy and purpose. And then let's first choose our output variable, which is not fully paid, right? And put it in output section. And all the continuous variables go under selected variable. Binary classification for output is 2 classes. Success probability cutoff is 0.5, and we have 2 classes. And then the top part is just the data source. Let's click on next to go to parameters section. So please follow me here. In the first part, pre-processing, we have the option to partition data. So let's check that. Check this box. 60% training, 40% validation. We just accept the default. So you could either partition the data initially using the ribbon or just use the partition on the fly, which is this. So when we say on the fly means in the algorithm, it's an option. So we did the partition. You have option to rescale data. Okay, just want to show you. Then you have decision tree fitting options. I just leave the defaults. You have advanced prior probability options. Okay. In the next example, I'll talk more about all of this. You can prune the tree, use it, for example, best prune tree, and you can show the feature importance and much more. But let's move on to scoring. I keep the default for scoring and simulation. Risk analysis, this simulate response prediction, will change the focus from how accurately a machine learning will predict a single new case to how it will perform in aggregate over thousands of millions of new cases. Furthermore, it helps us find out the business consequences and assess the risk that the machine learning will perform differently on new data versus training and validation when put into production use. Okay. Now, behind the scene, we detect and model correlations among features using rank order and copula, perform synthetic data generation. We use Monte Carlo methods for stratified sampling and correlation, and then we compute the machine learning models, predictions, as well as user-specified financial consequences for each simulated case. Okay, and then we assess and quantify the differences in the performance of machine learning model on the simulated data versus the training, validation, and test data set. So far, we chose the data. We are in the section for partitioning. But we did the partitioning, we are in the simulated data response section. The first part is MATLAB. Remember that the synthetic data generation does exactly the same thing, correlation fitting, and some sample size. So I'm going to use the sample size of 5,000. You have advanced options. Again, we talked about all of this. And then you can enter a financial payoff calculation, okay? And this is going to use Microsoft Excel table expression syntax. For example, we can calculate the financial loss of 12 times the monthly installment if the borrower defaults on the loan as a calculated risk measurements, okay? So to do that, at comes before the installment, the variable, close, and then 12 times. And you can this is all described in Microsoft how to use this syntax. And then you have to put at not fully paid. And these are the variables, right? Paid. Oh. And user guide will describe this in more details if you're interested. Okay. And then some expression hints if you're interested. So let's run this risk analysis along with the classification tree. Let's click on finish. And after a few moments, again, remember I'm creating 5,000 synthetic cases, so it takes a few minutes to get the results. Now, Analytic Solver data mining, it will create a classification tree machine learning model with parameters fitted to best predict or classify the training set known cases, and it then validates and refines the model based on validation known cases. Here is the classification tree output. We get the training log here, all the inputs to the model. This is the training score. Actually, this is the confusion matrix, number of cases that were correctly and incorrectly classified. Fortunately, if you look, the percent error for even the training set is 100%. Most of the people who would default, they are predicted as no default. Let's look at validation score. Same problem. This is the synthetic data output that we are familiar with. This example is actually an illustration of an extreme case of poor performance. And this is actually, one part is due to selecting and training only one type of machine learning model. We're just using decision tree. And the whole goal is here for me to show you that we're catching this poor performance early on by performing the risk analysis, and you saw the bad performance, okay? So let's go to simulation now, and we should be able to see the result. Here you have the not fully paid in a frequency chart. On the right side, you have the option. We can check the prediction, for example, on simulation and training. And you can see that these are the cases that all zero, there are no default, and there is no case that are predicted basically to default. We have the frequency for actual cases and the simulated cases. Basically what we see is this model is very unlikely to default on anybody. You can see that everything is one, right? That we don't see any zero case. And this is a risk that the model future predictive power is not very good at all. Okay. Now, you can try a different statistical machine learning approach for example, logistic regression, and you will actually get better performance. Problem with logistic regression, I just want to tell you in summary that it will likely perform differently on future cases. Overclassifying or significant number of low-risk applicants are likely to default. If you use ensemble methods, you will get a model that performs much better on simulated future cases. Okay, so you have to kind of try. One good option would be actually to use find best model. I'm going to show you in the next example how to benefit from find best model. Okay, there's much more information about this you want to dig into and understanding this further. And reference guide and user guide for data mining are really good sources. So click on help, and then you can click on user guides, and you have access to data mining user guide and reference guides. The important point of this model with the risk analysis that it alerted us that the possibility of unexpected model performance before it happens. It's not going to perform well in production. Okay, so you can gain some more confidence before putting a model in production use. Let's take a look at finding the best model options. We can appreciate the importance of finding the best model tool in reaching a precise prediction of mortality risk for patients and how that can influence healthcare and hospital resource allocation, leading to an improvement in healthcare services. So I'm going to switch to a healthcare dataset. Let's click on help. And for this one, we're going to use one of our shipping example models, forecasting and data mining examples, and let's look into clinical heart failure records. This medical dataset contains 13 variables describing about 300 patients experiencing heart failure, and our goal is to find the best model, fit the best model to dataset, and then use the fitted model to determine if a new patient is at risk of perishing due to heart failure using score option. Okay, and we are going to use best model to fit a model to all selected supervised learning classification methods in order to observe which method provides the best fit to our data. And this could be a step that we could use in the previous example, right? And also perform the synthetic data generation and perform risk analysis, because all of those are available within all the algorithms. So this event is column M, categorical. Let's click on data mining. One good option, you could use feature selection to find out what are the crucial factors that have the most predictive power in predicting morbidity. Anyway, let's click on find this model. We have both categorical and continuous variables. Our output variable is best event, age, serum creatinine, ejection fraction, platelet, serum creatinine, and serum sodium. These are continuous variable. Diabetic is 1 and 0, so it goes to categorical. High blood pressure, yes or no. Sex goes to categorical. Smoking goes to categorical, and anemia goes to categorical. And time of death is not really significant. If you run feature selection, we're gonna skip that. Let's click on next. Go to parameters. Okay, let's partition the data. Here you have partition data. You have prior probabilities, okay, that you can choose empirical. And this way, Analytic Solver will assume that probability of encountering a particular case in dataset is the same as frequency with which it occurs in the training data. Uniform, we assume that all cases occur with equal probability, and with manual, you can manually enter the desired classes, okay? So let's keep this. Here you have all the learners that we're comparing to find the best model. And you have the option to change parameters for each learner. For example, for logistic regression, you can change the parameter. For decision tree, you can change the parameter, and so on. And we're also using random trees and backend boost. These are ensemble methods. Next part, we have the find best model scoring. So we have different matrix for scoring. You have accuracy, specificity, sensitivity, precision, and F1. For example, accuracy refers to ability of classifier to predict the class label correctly. The next one is the proportion of negative classifications that are actually negative, okay? And sensitivity is proportion of positive cases that were classified correctly as positive. And for based on partition, in this example, I show for validation data set, okay? Let's go to scoring. Let's show you the detailed report and then click on finish. So here are the outputs. In this CFBM output, we get all the model inputs and output variables, okay? And in the lower part, you get the performance for model performance for training and validation, and the learner that is identified as performing the best internally is highlighted in red for you, okay? So the recommended learner for this model is logistic regression. And this is based off the matrix, and it shows all the matrix possible in combination based on the validation data set. Now we have the training score worksheet. This is the whole classification details. It's detailed scoring information for training and using the best learner, okay? Then the cases in red are the misclassified records. And then we also have it for validation. And on the top, you have the confusion summary. So you can see the percent error for validation and percent error for training. It's about 25% error for overall for training confusion matrix. Any questions so far? So it helps us to choose the best model. And then you also have the PMML model. This is the predictive modeling markup language. And all the models is stored here. So you can actually use this for scoring your new data in the future. As part of today's webinar, I want to show you how to create a workflow and go beyond Excel. So let's quickly open a new workbook and work on next example. Let's click on example models, forecasting data mining. I'm going to use wine data set. Where is wine? Let's go down. Here it is. It's a very straightforward data set, and it's about wine samples, 13 variables that describe different properties of wine from 3 different vineyards. Now that you're very familiar with classification, we have been using that. I want to show you a different way of using classification with creating a workflow and how you can compare multiple algorithms and also promote your model to use it on the cloud, okay? So let's go to data mining tab. Look at the task pane. So workflow is actually here, the task pane tab. You have 2 ways to create a workflow. You can create it manually, or you can actually, once you're performing different algorithm, you can click on start recording and it creates the workflow for you and from what the steps you are taking, okay? It allows you to have a combination of all available data mining techniques into an executable workflow. Let's go to first step. Where is my data? So let's first is where is my data? So click on get data, and you can see that I'm going to drag and drop get data. So you can see we have a question about big data. This is also part of this. Okay, you can sample from big data, summarize from big data. So drag from new, drag new, drop it here. Source data. This is the variables in our data. Let's select all the variables and click OK. To make it very quick, because I want to show you other things, let's go quickly to classify, and then you can go to ensemble method and, for example, use random trees. Okay, so drag and drop it here. Data is pretty obvious. We know output is wine type, and I think everything here is continuous, as I remember. Okay, let's click on next. You can check to partition the data. You have 10 weak learners. You can increment to, for example, have 20 weak learners, okay? And the weak learner here is decision tree. So this will tell Analytic Solver data mining to construct 20 different classification trees during the run, train each one on different subsets of data, and then combine the results to get a better classification, okay? So I can show you the weak learner models. You can show the feature importance and click on finish. So you can see that the workflow is completed here for us. We can actually format the workflow by clicking on this button to have everything like in center. And here the results of the classification ensemble method is presented. In the original model example I wanted to show you is to compare different algorithms. So for example, you can drag and drop logistic regression, classification tree, and then compare the improvement in the training score. And you can see here the percent error is 0, and for validation is actually it's only 5.6. But if you use, for example, regular classification tree, a weak learner, single weak learner, the percent error is about 12 or 13%. So when you can compare multiple algorithms. Okay, so this is how you can create an executable workflow. Again, you can click on execute workflow and it reruns everything for you. Okay, and all the wiki learners, which are different classification tree and different subsets of data, are also presented here. Okay, let's look into model deployment. We know now how to build a data mining workflow in Excel using Analytic Solver. And now we can easily share our model and its results with others in a repeatable and manageable process, which is called deployment. Okay, so let's click on Analytic Solver and let's click on Deploy Model option. So in this part, I want to go over some advanced capabilities of Analytic Solver that enables you to have your model to be used whenever and wherever it is needed. Okay, and this is possible by use of a cloud service, and this is by calling a Raison server. Remember, I told you we have another different product lines, and one of them is Analytic Solver, and then we have Raison Cloud Services, right? So good news is you can deploy your analytic models to the Raison Cloud Service and entirely within Excel. You see everything I'm doing here. I'm not doing any code. Everything is just point and click. You can actually use access manage models later on when you're interested, and you can actually check the runs, delete the models from cloud servers, and manage everything within Excel itself. There is also deployment wizard. Let me quickly show you if you're not sure what you can do. This also is a step-by-step help that can help you use these options, okay, if you're not familiar. So let's go back, deploy model, cloud service, and for data mining, let's use the Raison model option. Create app, cloud service, Raison model, and let's dive in. Let's call it wine test. Your workbook can reside on OneDrive, okay? Let's click on save, and within a few minutes, you will see that multiple things is going to happen. A new browser will open, and this is Raison.com. Raison.com is a front-end portal to Raison REST API that allows you to do a lot of things, including building and modeling not only simple models, but actually multi-step workflows where data and model results can flow from one stage to another. So we used Analytic Solver to create and test the model, fit a machine learning model, and we deploy the model to the cloud. So currently your model is actually sitting on the cloud. To clarify, let me show you a picture here. We are starting from Excel. We created everything in Excel. There was a workflow. Now we are able to use cloud service, promote the model to actually have it on Raison Cloud Server. It's an Azure hosted platform. And this is a Raison translational model, and I will show you that they actually have a decision flow in a diagram for any graphical form, or we can see the code in JSON syntax. So at the same time, when I did that to promote the model to have it on Raison server as a cloud service, Raison.com opened. It's a front-end portal to this backend server, and we saw the model here. And I'm going to go back and show you how, for example, we can run the model, get the results in Raison.com. So this is one way of communicating with server. We are displaying it in Raison.com and made it very easy for you to work with a cloud service. This is diagram editor. So we are using a model in Excel, partitioning, and then using random trees. And the results are showing in a graphical form. Remember that in Raison, you can do much more. You can have, for example, an optimization model results feed into a simulation model and then use in a data mining model. So this is not limited to data mining, but with workflow, we automatically create this for you, okay, in this diagram editor. Now, if you actually go to this button on the right side, it says show Raison model editor. And here is the JSON syntax in the Raison modeling language. We have everything. can see the whole model is automatically, the workflow is translated for us. If you wish to edit your model, you can do it directly here in Rayson, or you can make the desired changes in Excel workflow and then redeploy it, okay? Now, for example, you can do multiple things. Here, here's the model, right? This is the model. This is the log of communication that's happening with Rayson server. And in this side, we have properties of this model. There's a data file, for example, wine.xlsx. And here are all the models that I have under my account in Rayson. And you can manage all of these, the models from Rayson, from Excel itself. Remember, there was a manage model option. Now, on the top, you have options to run model and do model execution. For example, you can go ahead and click on post, solve. Now we are solving the model in that Rayson server, and we are getting the results in Rayson.com. Okay, so here are all the results. For example, you can choose. This is a OData format. The results are also available in JSON syntax. So I'm going to show you the JSON results. So you can switch between JSON outcome or OData results. And for our final demonstration, let's go back to the model. And let's click on Create App, Web Page. And actually, it's downloading Rayson script 4 for us. Here, a browser opens. We have a newly created web application from our data mining model. Remember, it was wine test, partitioning, winning data, partitioning, and then the whole model is translated in JSON syntax for us, okay? So Excel workflow that became a decision flow in Rayson, the whole thing is embedded in this HTML web page for us. And then you have different AJAX calls to actually solve the model. This was for a standalone, but this is a flow, so I have to remove it. I can attach the data file, for example, wine. And let's click on solve, and it's going to solve this for us, okay? Now you have the option to actually view page source. And here you can see how the communication is happening, and this web page is created for you. How in this web page we are communicating with the Rayson server. Everything you need to run the entire data mining decision flow on this single HTML page, bypassing months of work and development work by creating a web application that solves machine learning models on Rayson server by a few clicks. And the results, you can see the results in the message box down here. The template for this HTML page is shipped with our software. It sits in your examples, and it's called Rayson template. And you can open it in a browser, and actually you can also edit it. By using Rayson Create App, we learned an easy way to communicate with Rayson REST API beyond Analytic Solver and Rayson from a web application. This is a single standalone web application that you can use as basis for your web application. So this was just a brief introduction to just some of the features and enhancements of Analytic Solver, machine learning and data mining combined with the power of Rayson decision services. Excel would make it easier to get started with analytics. Remember, Analytic Solver is not just limited to desktop Excel. It runs on Windows, of course, Excel for Mac and Excel for the web, and works well with, for example, Microsoft Teams. And it offers all these tools from convenience of your browser. And today we explore two key components to our product line, Analytic Solver and Rayson Server. There's much more you can do when it comes to Rayson. You can create data connections, and you can create these multi-stage decision flows with automatic scheduling that are not limited to data mining or optimization or simulation. So with Analytic Solver plus Rayson, you can promote data science workflow to run them on Rayson Cloud Service and make the results available to other people. I invite you to start trying out Analytic Solver, data mining, and Rayson. So you are welcome to download your free trials, start exploring our products. And meanwhile, you're welcome to send any questions or comments to me at consulting@solver.com. I enjoyed presenting this webinar to you. I trust it was helpful. Here are some other contact information of some of our key team members. Thank you very much for your time. We appreciate it, and certainly reach out if you have questions. Have a wonderful rest of the day, and I hope to see you next week. Bye for now.